Euclid, one of the fathers of mathematics, created one of the most innovative and beneficial theory and proof techniques to this day.
Oh, hello there. I'm Euclid, and I can feel that I am on the verge of making a great discovery. What if there were an infinite number of prime numbers?
And so, Euclid's theorem was born. Euclid's theorem, also known as the infinitude of primes, states that there is an infinite amount of prime numbers. After thinking about it, Euclid attempted to create a proof of his concept.
Oh boy. If there is an infinite number of primes, it would be fundamental for number theory. But how could I prove this? What if I attempt to prove that there is a finite number of primes? If I can find a contradiction to this, then it must mean that there is an infinite number of primes.
And so he worked for hours upon end, a proof technique that he has tested before, but this theory could be seen as the origin of proof by contradiction.
Okay, so let's say there's a list of all prime numbers, P1, P2, continuing to Pn, where Pn is the last prime number. Suppose that P is the product of all of these prime numbers. Now, imagine Q is a number equal to P plus 1. This allows for two possible scenarios. The first scenario states that Q is prime, which means that there are more prime numbers. The second scenario is that Q is not prime. However, this can be proven false. If all of the prime numbers before it are not its factors, then it must be a prime number.
And so, the amazing Euclid's theorem was born. The proof by contradiction technique has been used by mathematicians like Fermat, George Cantor, and Andrew Wiles. But one of its most notable uses is when Euclid himself used it to prove the square root of 2 is an irrational number. He assumed it to be rational and found a contradiction, therefore proving it irrational. It was also used to prove that the sum of an irrational number and rational number is irrational. Using this information, we can decipher the importance of this technique within the mathematical world. However, this theorem can also be applied in other fields. The infinitude of prime numbers also aids in computer science, as they are the building blocks for all integers, which are constantly seen in computers. The reason for them being the building blocks of all integers is the following. For every integer, there's a unique combination of primes that can be multiplied together to obtain that integer. A mathematician or computer scientist who this theory has been helpful for is Evelyn Boyd Granville, who is the second African American woman to earn a PhD in math. She was born in Washington, D.C. in 1924. Boyd went to New York Institute for Mathematics, where she taught and conducted research. In 1956, she moved to IBM and soon moved to New York, then Los Angeles, where she worked for the US Space Laboratories. She was amazing in what she did, which was helping in computer procedures and orbit computations for NASA's projects, both Vanguard and Mercury. Euclid's proof by contradiction and the theorems proved has since been used to explore, develop, and prove more advanced theorems in various fields, not limited to mathematics.